Good morning, dear doctors and professors. Thank you for recognition of our team's work in aging and for giving us this opportunity to share our expertise today. My name is Zhang Pengcheng, from the postgraduate team of Professor Tian Li-Ming, who is the postgraduate tutor of Wuhan No.1 Hospital affiliated to Tongji Medical College of Huazhong University of Science and Technology in China. It is a great honor to exchange and study with renowned international experts and scholars. Professor Tian Li-Ming regrets his absence today, therefore hereby authorizes me to attend this conference on behalf of our team and have a share. So, let's get started. The topic our team is going to share today is Artesunate treatment, ameliorates ultraviolet irradiation-driven skin photoaging via increased beta-catenin expression. As we know, skin photoaging represents a vitally complex and coordinated biological event. Once photoaging begins, collagen fibers will degrade, resulting in sagging skin and wrinkles. Long-term ultraviolet UV radiation that is emitted naturally from the sun and artificial sources is the main cause of photoaging. And increased evidence suggests that UV radiation initiates skin photoaging through inducing oxidative stress and reactive oxygen species ROS production, thereby destroying cell micromolecules like protein, lipid, and DNA, weakening the skin's endogenous antioxidant ability, and inducing collagen and elastin fiber degradation. Decreasing the accumulation of intracellular ROS has become an effective strategy for preventing UV-mediated cell senescence and skin photoaging. Artesunate ART is a semi-synthetic derivative of artemisinin. It has attracted more and more attention due to its anti-malarial, antioxidant, anti-inflammatory, anti-cancer, and other biological activities. Studies have reported that ART may suppress tumor progress, liver fibrosis, and other syndromes while blocking beta-catenin pathway. Moreover, limited evidence suggests that ART has the potential to treat skin-related diseases. For instance, ART ameliorates atopic dermatitis through downregulation of Th17 cell response. Additionally, it can also relieve imiquimod-induced psoriasis like dermatitis. However, the therapeutic effects of ART skin photoaging remain unclear. Can ART ameliorate ultraviolet irradiated skin photoaging? Herein, we investigated that in hacked cells and mice. We use different concentrations of ART to pre-treat skin photoaging cellular models, mouse models, and normal cells with Sh-beta-catenin transfection or XAV 939 treatments. After 5 days, cell senescence, ROS production, SOD levels, P16N4A and Beta-catenin expression, proliferation, and apoptosis were detected as skin photoaging was then observed. Firstly, to observe the therapeutic effects of art on UV radiation-induced skin photoaging, we determined the TC50 of art in Hackett cells. Based on the TC50, Hackett cells were pretreated with 3 concentrations of art, 1, 5, and 20 micrograms per milliliter for 2 hours, and irradiated by UVB 20 millijoule per square centimeter. We found that art pretreatment significantly reduced senescence-associated beta-galactosidase positive rate of UV radiated Hackett cells with a dose-dependent manner. To clarify the mechanisms by which art protected Hackett cells against UVB radiation-induced skin photoaging. Intracellular ROS levels were tested by flow cytometry, and art pretreatment distinctly decreased intracellular ROS levels in UV irradiated cells. The mechanisms underlying art-induced decrease of ROS were explored by measuring the major antioxidant SOD used its detection kit. Art pretreatment significantly elevated expression in UVB irradiated cells with a dose-dependent manner. We detect the expression of cell senescence marked P16N4A and cell growth marked Beta-catenin. Art pretreatment distinctly decreased the expression of P16N4A and elevated Beta-catenin's expression in UV irradiated cells with a dose-dependent manner. In a word, art pretreatment markedly reduces UVB irradiated cell senescence, intracellular ROS production, and P16N4A expression, and increased SOD and Beta-catenin expression in Hackett cells. Secondly, it has been shown that UV radiation reduced cell viability and induced apoptosis, so we used art to pretreat Hackett cells and observed the effect. We found that art pretreatment ameliorated the inhibitory effects of UVB radiation on cell growth, and significantly decreased apoptotic levels of UVB irradiated cells with a dose-dependent manner. Does art treatment have toxic side effects on normal cells? Then we did the corresponding experiments. Interestingly, art treatment ameliorates UV irradiation-mediated cell senescence and has no toxic side effects on normal cells. And to investigate the roles of Beta-catenin on irradiation-driven skin photoaging, we designed shRNAs against Beta-catenin to silence beta-catenin and XAV939, which selectively inhibits beta-catenin-mediated transcription. The results showed that SH-beta-catenin and XAV939 significantly aggravated the decrease in beta-catenin expression in UVB irradiated Hackett cells. Nevertheless, ARCH markedly elevated the expression of beta-catenin under SH-beta-catenin transfection or XAV939 treatment. So, our treatment reduces cell senescence, P16-INK4A expression, and intracellular ROS production, and increases SOD expression in UV-irradiated Hackett cells by increasing beta-catenin expression. As we have proven before, our treatment enhanced cell viability and suppressed apoptosis in UV-irradiated Hackett cells. And our flow cytometry results showed that cellular beta-catenin induced by SH-beta-catenin or XAV939 markedly exacerbates the apoptosis of UVB irradiated Hackett cells. The effects were distinctly ameliorated by ARCH treatment. Connectively, our treatment exerted an inhibitory role on apoptosis and promotes the proliferation of UVB-irradiated cells by enhancing beta-catenin expression. We further observed the effects of our treatment and beta-catenin senescence in UV-irradiated skin photoaging in mice. These consequences also suggest that our treatment suppressed apoptosis, intracellular ROS production, promoted SOD production, and ameliorated collagen fiber and elastic fiber damage in skin tissues of mice by increasing beta-catenin expression. As it's shown before, oxidative stress exerts a key role in both natural aging and photoaging, and this effect is strengthened during the photoaging process. During normal physiological conditions, a series of antioxidant enzymes work together to maintain a low level of ROS in the body. SOD converts cyclic oxygen into the less reactive compound hydrogen peroxide. UV-induced ROS can cause extracellular matrix damage through a series of conduction and transcription mechanisms, forming rough wrinkles, pigmentation, and other skin photoaging symptoms. Herein, we determined the TC50 of ARCH in Hackett cells. According to the TC50 value, we set 3 concentrations of ARCH and investigated their effects on UV-irradiated Hackett cells. We found that ARCH suppressed cell senescence, intracellular ROS production, and increased SOD and P16-INK4A expression in UV-radiated packet cells with a dose-dependent manner. And our further also suggested that 20 micrograms per milliliter art had no toxic effect on normal cells. At the same time, we found that beta-catenin expression was distinctly lowered in UV-irradiated cells. As a previous study, it has been found that beta-catenin signaling activation could induce monogenesis in monocytes. Our study found that our treatment elevated beta-catenin expression with a dose-independent manner, indicating that beta-catenin might be a target of ours. Standard beta-catenin by SH beta-catenin or XAV 939 aggravated cell senescence, intracellular ROS production, apoptosis, and P16-INK4A expression, as well as weakened the increase in SOD expression and cell viability in hacked cells irradiated by UV, which was ameliorated by our treatment. To confirm the therapeutic effects of art on skin irradiation, we established mouse models and got the same results as in the previous cell experiments. However, a limitation of animal experiments should be pointed out. To study the effects of beta-catenin on photoaging in vivo, SH beta-catenin adenovirus was injected between the dermis and epidermis of the irradiated site once a week for the mice. Nevertheless, the specificity of this method is limited as all the cells in this area would be interfered with by the virus, not just the epithelial cells used by the authors in vitro experiments. And in our future, CRE-fluxed knockout mice will be used to verify our conclusion. To conclude, this study suggests that our treatment exerted an inhibitory effect on skin photoaging, both in UV-irradiated hacked cells and mouse models. Further analysis found that beta-catenin was responsible for UV irradiation-mediated skin photoaging. Mechanically, art treatment ameliorated skin photoaging by enhancing beta-catenin expression. However, our findings offered novel clues for pharmacological activity of arts. Okay, thanks for listening. We greatly appreciate Alex's response, approval, and invitation to our team, and sincerely wish the international webinar a success.